All right, people, let's go. A bit of chemistry. So, if you're in year 12 or year 13, if you're in year 12, you might have some end of unit tests coming up. And one of the early things you do in A level chemistry is like moles, ideal gas equation, basically amount of substance. So that's what this lesson today is on amount of substance. Also, if you're in year 13, you've got mocks in November, December, or January. So you might want to be revising this kind of stuff. So moles, ideal gas equation, titrations. Basically, what I'm going to do today, there's a really useful website. You've probably heard of it before, but you should know it by now, and that is if you just go to Google and you type in physics and maths tutor. I'm sure you guys have used this before. So just Google physics and maths tutor. The first thing that comes up is the website for physics and maths tutor. Now, there's a downside to this website. You do get adverts and things like that coming up, but it's free, so you're not paying a subscription or anything. Obviously, they have find a tutor and things like that. I'm not interested in finding a tutor. Go to A level. Just hover your mouse button over A level, go to chemistry revision here. Now, depending on your exam board, you can now select, you see here, it's come up with Stefan C, £60. Oh, £60 an hour, jeez. All right. So it's come up with tutors, right? I need to up my prices, boy. Yeah. Anyway, you've got GCSEs here, but of course we're interested in A level. So you can now pick your exam board. I'm going to be using AQA questions today, but they're all applicable to OCR and EdXL. So you click on AQA there on this website. Now comes up with all of this stuff. So I'm going to go physical chemistry. That's where you're going to find moles and things. See, there's an annoying advert for some pens. I don't need any highlighters, but still. You click over here, another tutor, Hamza, he's £60 an hour as well. Whoa, these guys are charging some money, all right. Now what you'll see are questions over here, detailed notes, model solutions for calculations, mind maps, videos, flashcards, all sorts of things. I'm really interested in just looking at exam past paper questions. So that's what I'm going through today. I'm going to hover over amount of substance. You can click on amount of substance like that. And but my computer gets round to it, will load up. Yep, I'm mic'd up. That would have been embarrassing if I wasn't. Now you see, look at all of these questions on amount of substance. So this is pre 2016 papers down here. Loads and loads and loads and loads. Okay, those are very, very useful, but you want to concentrate on the more recent papers. So up here, these are questions from 2016 to 2021. So they're very recent. They're of the latest specifications. So they're the ones we're interested in. Going to click on amount of substance here. And then you've got all of these questions, right? Now, what I recommend when using physics and maths tutor is that you duplicate the tab. And then you also, so how you would work through this pack, you would then go back here to the main menu and you click on the mark scheme for those. And there you have the mark scheme to go alongside the questions. So you can just flip between the tabs, have a go at a question on a piece of paper, then check the mark scheme. That's the best form of revision. Okay, obviously some of these will be very, very difficult, and I'm going to go through the first like maybe 5 to 10 questions in today's lesson on the amount of substance from this website, Physics and Maths Tutor. So I've already transferred them over to my whiteboard. So let's go, let's get into it, and I'm going to work through these questions. But I seriously recommend that you add Physics and Maths Tutor to your favorites tab on your PC. It's got all the stuff there for you to succeed. There are some other websites. I'll talk about some other websites. I might do a review of them, the different websites for A level and the kind of questions you've got. Physics and Maths Tutor is good. It's brilliant, actually. The only doubt, it organizes the questions really nicely. You've got mark schemes. You've got everything you can possibly want to get the A star at A level. The only thing is you get adverts popping up over the screen. But other than that, it's a superb website. Right. Let's go. Let's get into it. Woo! This is question one. Amount of substance. Calcium sulfide reacts with calcium sulfate as shown. We've got calcium sulfide here, CaS, plus 3 molecules of calcium sulfate. Okay, and this goes to calcium oxide, 4 molecules, and 4 molecules of sulfur dioxide. Now the question tells us we've got 2.5 grams of calcium sulfide and they're heated with 9.85 grams of calcium sulfate until there's no further reaction. So the reaction's complete. Show that the calcium sulfate is the limiting reagent in this reaction. Now you may have done some of these at GCSE, limiting or excess, especially if you did triple science. Calculate the mass in grams of sulfur dioxide form. So we've got a second part to the question as well. And they've been very nice and given us the MR of calcium sulfide and calcium sulfate. So we don't have to go searching around in our periodic table for that, which is great. Let's get on with the question. The first thing I recommend doing when you get a question like this is highlighting some of the key bits. So I would highlight, well, my highlighter tends to blank it all out, but I would highlight the 2.5 of calcium sulfide. All right, let's get rid of that because that's just hiding the actual information. It's not much of a highlighter. I blame Google Jamboard. Right, calcium sulfide, 9.85 grams, and we got 9.85 of calcium sulfate. And then the question, they've told us calcium sulfate is limiting. As soon as you see grams, as soon as you see MR, you should be thinking moles. Yeah, well done if you made that connection, because that's what you should be doing, of course.
You absolutely smashed it.
Right, let's get in. Here we go. Let's go. First step, let's work out how many moles of calcium sulfide we've got. So let's start there. We're going to moles of calcium sulfide. Ooh, get off that pen, please, T. Right, we got 2. Got a thicker pen than that. Scribble, scribble, scribble. We've got 2.50 grams of calcium sulfide. We know that the MR is 72.2, and I like to write the units because sometimes when you get deep in an equation and you look back at some of your numbers, you can be like, oh my gosh, what was that? Was that moles? Was that mass? What does that number represent? So it's best to get in the habit of writing the units there, like grams for the mass, MR for the MR, etc. So if I do that, that's going to give me the moles. So whip out the calc, and that's going to give me 0.0346 moles. Now I use N for number of moles, the best thing to use, because if you put an M it starts to look like mass or something like that. So now that's our moles of calcium sulfide. Your next step is to take it like a reacting mass question. Have a look over here. The ratio of calcium sulfide, where's the spotlight? There it is. So the ratio of this calcium sulfide to the calcium sulfate, what's the ratio based on the coefficients in front? What is that ratio? Yeah, you got it. It's 1:3. You don't need to write a 1 when the coefficient is 1. You just leave it blank. So it's cool.
You absolutely smashed it.
So we know the ratio is 1:3, which means I should be making, and I need to label this, by the way, as well, because if you don't label that, you might start to worry about what you've actually got. So what we're going to do here, they're asking us to prove that CaSO4 is limiting. There's not enough of it. First of all, we need to work out how much should we have for all of the calcium sulfide to react. So the ratio is 1:3. So we need to times the moles of calcium sulfide. That would help if my face went over everything. Let's zing. Ooh. Okay, shrunk down. So the moles of calcium sulfide, we should have 1 mole of calcium sulfide for 3 moles of calcium sulfate. So let's times 0.036 by 3, or 346. And we should have 1 or 0, read my calculator, 1038 moles of calcium sulfate. That's how many we should have. Now, sometimes the question will be asking you to find out what the limiting reagent is. Here they've told us the limiting reagent. So what I would do now is, how much calcium sulfide have we actually got? Let's check out the actual amount of calcium sulfate. So what's the actual amount of calcium sulfate? And that we can find out what the actual amount is by doing 9.85, which is the actual mass we have, over 136.2, and that's the MR. And guess what? Kind of not leaving myself much room, am I? No. I like to get all over the place here. So let's do that sum and find out what that is. 9.85 divided by 136.2. We've actually only got 0.072 moles of calcium sulfate. Okay, so that's not going to be enough. And that means that all the calcium sulfate is going to be used up. So this is the actual amount of calcium sulfate we have. And that means that all of the calcium sulfate is going to be used up. And we're going to be left over with some of the calcium sulfide. Okay. So we have proved that calcium sulfate is limiting by doing this. We should have this. We've got that much. So you get a mark for each of this. You get a mark for showing the ratio, a mark for explaining why. So we can, if we want, we can say, we could write down a little sentence saying we don't have enough calcium sulfate. We should have 0.1038. So how much we need, that's how much we need, and how much we've actually got. Yeah, we don't have enough. Okay, so we haven't got enough. What does that prove? That proves that the calcium sulfate here is limiting. There's not enough. So that scored us like 3 out of 5 marks here. They also want you to calculate the mass in grams of sulfur dioxide form, the second part to the question. Now, should I use... This is like a reacting mass question. So if I know the moles of calcium sulfide or calcium sulfate, I can use the coefficient to work out how many moles of sulfur dioxide will be formed, and then I can work back to find the mass. Here's the mistake some people will make. They might go off of the 0.0346. They might say, well, look, the ratio of calcium sulfide to sulfur dioxide is 1 to 4. However, why can't we use the calcium sulfide? You should be able to work out why we can't use the calcium sulfide. Of course, it was in excess, so not all of it reacted. We're going to need to use the calcium sulfate because we know all of that reacted. That's the limiting reagent. So we can only make the amount of sulfur dioxide dependent on the moles of calcium sulfate. So you know that.
Boom!
All right, so let's get to work and do that. Let's make that. So we got 0.072 of the calcium sulfate. And what's the ratio over to the sulfur dioxide? What's that ratio going on here? What ratio? 3 to 4. Right, the ratio is 3 to 4. Am I expecting the moles of sulfur dioxide to be bigger or smaller? If the ratio is 3 to 4, is it bigger or smaller? Doing these little mental things which are nice and simple, of course it's going to be bigger because we're going from 3 to 4. So it's going to be bigger, the amount of moles of sulfur dioxide. Doing these little mental checks will help you avoid slip-ups and give you confidence in your answer. So How do we do that? Well, we multiply. When you want to go up, when the ratio is 3 to 4, you're going to multiply by 4 over 3. Okay? And when you do that, let's see what we get. 0.072 times 4 divided by 3. We are going to get 0.096 moles. Whoa. Okay, remember I use N for moles. So here we go. We have scored another mark. So there are 4 out of our 5 marks scored right here. By finding out the moles of sulfur dioxide, we now have scored the 4th mark. The final mark in this question is to convert that to grams. And of course, you guys should know off by heart, anytime you see grams in chemistry, you need to recall from GCSE your mass over MR times moles. Okay, little magic triangle. So we're going to do mass. We need to find the mass. So we're just going to times the MR of sulfur dioxide by the moles. We've got the moles. So what is the MR of sulfur dioxide? Well, if you look up in your periodic table, by the way, if you're studying chemistry A level, anytime you sit down to do revision and work, you want a little space, a clear space at home. Not like my space, I'm all jammed in here with like my calculator and everything. You need a scientific calculator. You can get these dead cheap on like eBay, just some basic £5, £10 scientific calculators. I suggest having more than one, right? Backup, because you don't want to be sitting down to do revision and realize you can't find your calculator. So I've got about 5 of these. You want backup to have some of these lying around, a couple of these scientific calculators. You want a nice space to work, a little desk space in your room or somewhere in the house you can work, a little bit in the living room, a little bit of the table in there. And you need your periodic table. So if you haven't printed a periodic table off, print one off, stick it up where you're working. You're an A-level chemist. You need to be referring to the periodic table all the time. It needs to become like your best friend, okay? And that will help you when you're sitting down to do questions. You're ready to go. So, right, let's times those moles by the MR of sulfur dioxide. Sulfur is in group 6, 1 below oxygen, mass of 32.1. Oxygen, 1 above, mass of 16. But we've got 2 oxygens, so we want to do 32.1 plus 16 times 2. And we will get, should be 64.1. That is the MR of sulfur dioxide. So although they were kind of gave us these MRs, they wanted you to work that out. And that's fairly all right. Let's see what that comes out as. 0.096 times 64.1. Whee! I think it was 0.0964 times 64.1. So, yeah, I got, it was actually 0.0964. I should really maintain a high level of accuracy because, so I got that, which you can then round up to 6.18 grams, and that's the answer. Okay. So the actual moles here were 0.0964. I should probably stay with those for my calculation. That gives me a different answer. If I just rounded that to 0.096, I'll get 6.15 grams, and which is what I got the first time I put it in. And then I referred back to my calculation and saw, oh, okay, it's making quite a big difference to the answer. It's 6.18 grams rounded up if we do it with the proper amount of moles. All right, guys, that's the first question done. Well done. What we're going to do now, we're going to move on and do a couple more questions. Remember, the questions I'm going through today are found on the Physics and Maths Tutor website under AQA, under the amount of substance, 2016 to 2021 papers. So these are all relevant to your exams. These are all the latest style of questions. These are all from your specification. You need to know all of this, and hopefully this will help you. Right, let's move on.
Keep moving on, keep moving on, keep moving on, keep moving on.
Okay, so what we're going to do, we're going to go through as many as I can today in an hour, and then I will do all of the questions. There's like 40 questions on here, but I'm not doing them all today. I'll probably do them over like 2 or 3 lessons this week, so let's go.
Stick around.
I'm gonna have to science the shit out of this.
Yeah. Let's go, let's go. Okay, whee, another big question. Oh, whoopee doo. Right, let's get into this one. Mic check, all good. A student is provided with a 5.60. Immediately, I'm thinking moles, right? You're a A-level chemist now. The moment you see stuff like this, ooh, grams, you got to be thinking, I'm going to need to do a mole calculation at some point. So I'm already thinking at some point, I'm going to need to do mass over MR, and I'm going to need that calculation. So you need to have these in your head. You need to start analyzing as you go through. You must use a highlighter on the question. So a student is provided with a 5.60 gram sample of ethanoic acid contaminated with sodium ethanoate. We're going to have to do a purity calculation at some point. We're going to have to find out how we're going to have to separate those two things. The student dissolves the sample in deionized water and makes the volume up to 200 centimeters. Here's our next bit of information. So we've got 200 centimeters solution. They've dissolved it and it's now in a solution of 200. The student removes 25 centimeters. They love to do this if they're going to do a titration. Make a big stock solution and then remove a small bit to carry out their titration. The samples of the solution and titrates them with 0.35 sodium hydroxide solution. So what I'm looking at here, guys, oh my God, that's like the worst circling I've ever seen, is what have they done? They have diluted, well, they've made a solution, but then out of 200, they've taken 25 centimeters. If we do 200 divided by 25, they can do this 8 times. There's 8 portions. So this is, they've basically taken an eighth. I always like to write a little times 8 here. There's 8 lots of that in 200. At some point, I'm going to be asked to find out what was in the original 200 centimeters. So I know I'm going to have to multiply by 8. It's a little thing as I'm going through. I want to do, I'm going to need to find like moles or whatever. I want to like write little things down as I'm going through, making notes. So I know little highlighted notes. Right, I've got the concentration here as well. That tells me I'm probably going to use this second moles calculation, moles, which is N over C times V, and you know that from GCSE. So immediately I'm thinking, right, they've given me mass, I'm going to have to use mass and moles. I might not have to, but I'm predicting that. They've given me a concentration, I'm going to have to use concentration and volume. So the first section to this question, we then get a table of results with a rough titration. Not interested, we're not going to need those for calculations. And then we've got final volume, initial volume, but they've given us they've done the maths for us, so they're not asking us to work out the titras. Here are the 3 titras. Use the results in the table to calculate the mean titra value. Use the mean titra value to calculate the percentage by mass of sodium ethanoate in the original sample. So it's 6 marks. Woo, it's a big boy question or big girl's question. Sodium ethanoate, they want us to find out how much of that was contaminating the original sample. And the first step is calculate the mean titra. So we look at these 3 results here, titra 1, 2 and 3. Which of those 3 results are all within 0.2 decimal places of each other? Which are all within 0.2? You know that. .25 and 20.30. You might say to me, sir, yeah, 20.50 ain't there. It's not within the range because it's 2.5 away from this one, 0.25 away from that one. So we're not going to include that. It doesn't bunch in together. So we're going to do 20.25 plus, this is going to get us our first mark calculating the mean titra, plus 20.30. We're going to divide that by 2, We don't divide by 3 because we're discounting that second titra. And let's whack that into the calculator and see what we get. Okay, we get, I don't know why I'm writing in blue, that's kind of mental. We get 20.275, and that's our mean titra. Now, what have we just calculated? What is a titra? Well, a titra is the volume. You can tell that by the centimeters cubed. So I've now got volume. Well, up here I've got concentration. We're going to come to this first magic triangle of moles, and we're going to find out how much sodium hydroxide over here we've got in moles. We know that that neutralized the acid in this 25 centimeter sample. So that's going to tell us how many, once we times it by 8, we're going to find out how many moles of acid were in the original 200 centimeter solution. And that means we can work out how much mass of that is ethanoic acid, and therefore how much mass of that is sodium ethanoate. So now I've said that, you might want to pause the video. You might want to go through and try this on a piece of paper. You should really do that with all of these. You could print off the physics and math tutor pack or work through them and then use this as an explanation for the ones you can't do. All right, let's go. Okay, so first step first here. We've got that. What do I need to do with the volume here? My volume is 20.275. Well, I need to turn that into, let's do this, right? 20.275. I actually need to turn that into decimeters. You should remember how to do that. Divide by 1,000. And then I can times that. That's the volume. And I'm going to times that by 0.350. And this is going to give me, and that is mole dm to the minus 3. Don't really need to write all this out. It's my calculation. And that is going to give me, well, what is that going to give me? That's going to give me my moles of sodium hydroxide. So moles of NaOH. And let's do it. Okay. 20.275 oh, it helps if my calculator's on. 20.275 divided by 1,000 times 0.350, and I'm going to get 709 times 10 to the minus 3. Yeah, that's cool. That'll do me. Right, 7.09. Okay, 625. I'm not going to round yet. I make that mistake sometimes of rounding, which too early. And that, what is that I've just calculated? You might want to put, that is NaOH moles, or I could really put the N not there. That might look a bit freaky, but that's moles of NaOH. So I've calculated the moles of sodium hydroxide. That's an alkali that was used, that was titrated with our 25 centimeters of contaminated acid. So I now know that it will have neutralized the ethanoic acid, so I can work out my moles of ethanoic acid. Okay, you might say, sir, how do I know the ratio of sodium hydroxide to ethanoic acid? So we can write out the full equation if we want. All right, we can write that full equation out if we want. But there's a little clue without you writing the equation out. Ethanoic acid has got one hydrogen to donate, and sodium hydroxide has got an OH. So it's going to be a 1-to-1 reaction. 1 mole, because the H and the OH get together to make water during the neutralization of that alkali and acid. Ethanoic acid is only donating one single proton, and sodium hydroxide only has one hydroxide, so they're in a 1-to-1. If it was magnesium hydroxide or calcium hydroxide, that would have 2 OHs, and so you'd have 2 alkalis to every acid. Or if it was hydrosulfuric acid, it would be like 2 protons, so it's a diprotic acid, so that would change the ratio. So here I can tell the ratio is 1-to-1 without writing out the equation, but just in case you want me to write out the equation, I don't know if I can be bothered to write the equation out. Let's write the equation out just to show you that it's 1-to-1. CH3COOH. We're going to plus that to NaOH. Boom, boom, boom. Little arrow. That's going to make sodium ethanoate, which we already have contaminating our acid solution, and that's going to make water. So when we do that, we can see that it is a 1-to-1. Okay, so that's a 1-to-1 reaction. So now I know the moles of sodium hydroxide. I also know the moles of acid, right, in the 25 centimeters. So I want to acknowledge to the examiner that I know it's 1-to-1. So I'm just going to put 1-to-1. So that means I have 7.09625 moles HCl in 25 centimeters cubed. Because they neutralize, they reach the end point there, I now know that there is that many moles. Did I put times 10 to the minus 3? Did I know? Okay, there's that many moles of hydrochloric acid in 25 centimeters. But remember, I made my note earlier so I didn't forget. Over here, I put times 8. We diluted the original acid solution down by only taking 25 out of 200. 200 divided by 25 is 8. We used 1/8. I need to multiply these moles back up to find the original moles, not of hydrochloric acid. Why am I writing hydrochloric acid? Oh my good gosh. Oh gosh, do I have to write this out? Yeah, so let's times by 8. Anyway, enough of my waffle. Let's times that by 8. So we want to times that by 8. And if we do that, we get the original moles of ethanoic acid, not hydrochloric acid, 0.05677 moles of CH3COOH. Now I need to convert this into grams. I want to find out how many grams of ethanoic acid there are, and then I can subtract that from the 5.60 and find out exactly how many grams of sodium ethanoate we had. Okay, so that's the moles of ethanoic acid. Let's do the maths. Okay, guys, if you can work out the MR of ethanoic acid, then you're a hero. So we want to do MR times moles. So the moles, basically count it up. There's 2 carbons, 12 MR each, or AR. That's 24. We've then got 2 oxygens, which is 16 each, is 32. 32 and 24 is 56. How many hydrogens in ethanoic acid? Well, there's 3 and another one is 4. So ethanoic acid has an MR of 60. And we're going to multiply that by the moles of 0.05677. And this is going to give us the grams now, the actual mass of ethanoic acid in the original 5.6. So let's do that. Times 60. We've got 3.40. Sorry, some of my buttons aren't working properly. Of ethanoic acid. We're still not there. We're still not at the end of the question, peeps. We've now got to work out how the question was actually, rereading the question, asking us the percentage mass of sodium in the original. Now we need to find out the grams of sodium ethanoate. So we're going to do 5.60, which was the total contaminated supply of acid, minus the pure acid that was in there, 3.4062 grams. And this gives us the grams of sodium ethanoate. So let's go. 5.60 minus my answer gives me 2.19. 2.19, is that 38 grams? And what is that of? That is of CH3COONA. That's the sodium ethanoate that was contaminating it. Now I need to work that out as a percentage. So we do difference over the original 2.1938 over 5.60 times 100. So it's not even 50%. It looks, well, maybe it is. Let's see. I shouldn't, let's whack it in. So 2.1938 divided by 5.60 times 100. We get our final answer. All that work for 6 marks. Jeez Louise. $39. My phone is blowing up here. I don't know why. And that is the final answer, peeps. If you can follow that, you're incredible. So, yeah, chemistry is not easy, but there's your 6 marks written out with all the calculations. So I hope that's going to help you when you're going through and you're trying to answer these questions. Sometimes when you go to the mark scheme, the only downside to going to the mark schemes for exam questions is they often don't have the steps in the way or an explanation. So what I like to do is just add a bit of that in there and talk you through. Make sure, by the way, that if you're watching the video and you find it useful and it's helping you with your revision, please make sure that you smash the like. That's really important. I need to shrink my face again because I'm over the top of a little bit of my working. Oh my gosh. I'm getting smaller and smaller. Oh! Yeah, make sure you smash the like, guys. Thank you. That will really help. And leave any comments, any topics or things you want me to go over. I'm going to keep going for another 25 minutes before I pack up for today. And I'm going to work through all of these questions come this week, basically, and next week. Hopefully in preparation for your end of unit test.
If you push the button,
Like me.
Would you like it?
Like.
Yep. Let's go. Next question. Oh my good gosh. Right. This question is about 2 experiments on gases. In the first experiment, liquid wire is injected into a sealed flask under vacuum. This is all the waffle that you get. You kind of got to zone yourself into, when you're reading a chemistry question, you got to highlight on the facts, keep to the facts, use a highlighter, circle things, make notes. You might need to come back to it later when you're doing the calculation. The table below, the liquid vaporizes in the flask. So they've got a liquid, it's been injected into a sealed flask under vacuum, which has caused it to vaporize. Here's the data. We've got the mass. Oi! As soon as you spot mass, what should you be thinking? You should be thinking, soon as you see it in chemistry mass, you should be doing mass over moles times mR. You know that from GCSE. It's going to come up again and again. As soon as I see mass, that's what I'm thinking. I also want to make a note, a little squiggle here. Milligrams. Yikes. I've got mg. Milligrams, 1,000th of a gram. I might need to convert that to grams because you don't really want to be using your milligrams with moles. The mass when we're using moles is in grams. So I might need to convert this. So I'm making a highlight. I've got temperature. Temperature's in Kelvin. That's good. We like the temperature in Kelvin. The volume of the flask is in centimeters cubed. I might need to come back to that depending on what type of question this is. The pressure inside the flask, they're giving me pressure, is 51 kilopascals. Calculate the relative molecular mass, that's the MR, so we know we're using this calculation. Show you're working. Remember that the gas constant is 8.31. As soon as you see 8.31, especially if you're year 12, you should be thinking ideal gas equation. Okay, you're going to have to use the ideal gas equation. If you're in year 13, you use R also in something called the Arrhenius equation, which is part of like reaction kinetics. But you should be thinking ideal gas equation. And that's confirmed by the fact we're talking about a gas. We're We're talking about something vaporizing. We're talking about it's an experiment on gases. They've even given us volume. So we should be bussing out our ideal gas equation now. So you need to be writing that down. And if you can remember the formula, you may get yourself 1 mark just for remembering the formula. So can you remember the formula for the ideal gas equation? Of course you can.
You absolutely smashed it.
So we want to write PV equals N for moles, R for the gas constant that they give you, and T for temperature. They've given us all the elements here, but in every ideal gas equation, you'll need to do at least 2 conversions, sometimes 3. They'll either put the temperature, the pressure, well, temperature, pressure, and volume are the 3 things that you might have to convert. Sometimes you only got to convert 2. They give you the one in the right unit. Sometimes you might only have to convert 1, but you'll always have to do a unit conversion. So first step to score the first mark is let's rearrange this to find what we need. We need to find the relative molecular mass. Now, in order to do that, that's the MR, I'm going to need moles, N. That's the only thing that's in this equation, the N. So I need to rearrange this to make N the subject. And I can do that by dividing PV by RT. So we get PV over RT equals N. And that's going to secure you, most probably, on most mark schemes, your first mark, the rearrangement. Now, second mark in the mark scheme is going to be to convert. So let's check this out. Let's write out this equation. Right, we've been given the P for pressure. Right, pressure is, they've given us 51 kPa. Hopefully you know that is supposed to be in just pascals. So we need to times that by 1,000. And if we do that, we're going to get 51,000 pascals for the pressure. There's a conversion. Now, you are also going to need to, you don't have to convert the temperature. Temperature's in Kelvin, that's good. Volume, this is the bit that a lot of people mess up with the ideal gas equation. What do? You need it in meters squared. What do a lot of students do? They go, right, I need that in meters squared. I divide it by 100, it's 4.82 meters, right? 482 centimeters. If you were dealing with a line, a straight line, 482 centimeters would be 4.82 meters. But we're dealing with cubes here. That little 3 means cubed. So we've got to divide by 1,000,000, 100 by 100 by 100 to find out how many meters cubed it is. So let's divide by 1 times 10 to the 6. And if we do that, we will get the conversion. And this scores you your second mark. You don't have to set it out like this. I didn't put V at the start there. You don't have to set it out like this at all. Like, you can just put it straight into the equation. But I'm just showing you. I keep like bussing out calculations without actually switching my calculator on. Right, 1 times 10 to the 6 equals 4.82 times 10 to the minus 4. So I'm going to go ahead and write this all out. I don't need to convert the temperature, and R is always 8.3. We don't need to convert that. So let's write this out. We got 51,000, guys, times 4.82. My gosh, I've never seen a 2 so bad. Times 10 to the minus 4. Why didn't I type this? Why am I writing it? Well, I've started, so I'll finish. 8.31, that's R. And the temperature's already in Kelvin for us. Beautiful. 297, which is almost standard conditions there. Let's carry that out and find out the moles, guys. So whack that in your calculator and let's find out the moles. So 8.31. Make sure you put brackets in when you're using your calculator and you're doing these calculations. If you don't break the calculations down, sometimes the calculator comes out with some funky answer. So the moles is 9.96. Load of noughts, so I can just leave it as that. Times 10 to the minus 3. That is the answer you should be getting in your calculator. Okay, and that's probably secured us 3 marks altogether, I would assume. So far we've got 3 out of 5 possible marks, because we've got 1 here for rearranging, got 1 here for the conversions, correct conversions. Now you can just do those correct. You don't have to write them separately. You don't have to do that. You can put them straight in here. The examiner will see you've converted it correctly. And then 1 for calculating the moles. Now we need to score the next 2 marks. We need to calculate the MR. So remember, we're now going to focus on this. Mass over moles equals MR. We have a problem. Mass over moles equals, in this case, the MR. We're going to do that. We have a problem with our mass. Remember here I highlighted, I made a little note, I just wrote mg, so it would trigger me when I look back to the mass and go, oh yeah, it's in milligrams. I need to turn that into grams. So I'm going to divide that by 1,000. So 717 over 1,000. That's going to give me 0.7, where's the little point? 0.717 grams. I'm then going to divide that by the moles. I don't know why I'm writing in green, peeps. I thought I was doing my ticks in green. Divide that by 9.96 times 10 to the minus 3, and that should give me the MR. 0.717 divided by answer equals 71.98. Okay. And then we're going to round that. Did they ask us for any significant figures or anything? No, but I would round that to 72 is the MR. Boom, boom, boom. You're going to get 1 mark for the conversion of milligrams to grams, and then 1 mark for carrying out the calculation of mass over moles and finding that the answer is 72. So give yourself, if you got that, give yourself a big pat on the back. Well done, well done, well done. So round of applause. Woo! Yeah, well done. Chemistry's not easy, is it? So, oh jeez, the question's not over. Right, in the second experiment, of course, in another flask is used for a combustion reaction. So we're using a separate flask. This means it's not going to have anything to do with the first experiment. We can leave all that information there. Generally, when they start, like, look, they're on part B. Generally, when they do that, we're on like a separate thing. So we don't need to panic now. Remove all the air from the flask. Okay, let's go through and sort this out. They added 0.001 mole of 224 trimethylpentane. Okay, C8H18. That's what I'm looking at. They added 0.02 moles of oxygen to the flask. They sparked the mixture to ensure complete combustion. Cool the mixture to the original temperature. Calculate the amount of moles of gas in the flask after the reaction. So this is really us just using some ratio business here. Okay. So what we want to do is ratio this up. We know that all of this completely combusted. So all of that C8H18 completely combusted. What's the ratio from that to that? Calculate the amount in moles in gas in the flask after the reaction. Okay. First of all, I need to do that to that. Okay. Right. Aren't these questions hard? Yep, they are. But you know what? We like a challenge because we're doing chemistry A level, don't we?
Say when.
one. Let's go!
All right. So we've done complete combustion. That means my oxygen, the O2, which we've got 12.5 oxygen as the coefficient compared to 1 mole of the trimethylpentane, they told us it was complete combustion. This means we've probably got more oxygen. So what's going to be left over in our flask? So when we have our flask at the end of this, our flask is going to have some gases left over. Well, it should have some oxygen. How do I know that oxygen's going to be left over? They told me the combustion was complete. Like all of the fuel had burnt. So I must have some oxygen left over. And then I've got a gas product, which is carbon dioxide. I can discount the water because the water is a liquid. That's not one of my gases that's left over. Let's just double check that there isn't some of the fuel left over, the 2,2,4-trimethylpentane. And we've read this right, that there's oxygen left over. Let's look at the ratio. So the ratio between C8, H18, and, well, let's just do it like that. Get rid of that arrow I've just done there. Can I have a rubber, please? Yes, merci. So, yeah, I'm on. Thought I wasn't mic'd. The ratio of the fuel to the oxygen is 1 to 12.5. So let's just make sure that there is oxygen left over. How many moles did we have of the fuel? We had of our, I don't want to keep saying it, 2,2,4-trimethylpentane, C8H18. I'll just call it the fuel. 0.0010. If I times that by 12.5 in the calculator right now, let's do it, people. 0.0010 times 12.5. We used up 0.0125 of oxygen was needed to react with the fuel. How much oxygen did we have? We had 0.02 moles of oxygen. So we're going to, obviously we have more oxygen. You can see it now. We take away the oxygen that was used up in the reaction, which was 12.5 times the fuel. And we are left with so we got 7.5 times 10 to the minus 3 of O2. That's how much oxygen is going to be in my flask over here, right? That's the oxygen I've got over here. That's how much is left. But that's not all of the gas. We also need to know how much carbon dioxide was formed. And this time, the ratio is 1 to 8. So I need to work out the ratio, or I need to work out the moles of carbon dioxide. Now, we can't go from oxygen. We have to go from the fuel, the limiting reagent, the thing that was all used up. And our limiting factor here is the fuel. That all got used up. We had leftover oxygen. So don't go trying to transfer your moles of oxygen to moles of carbon dioxide. That ain't going to work. So let's go with 1 to 8. So if I do 0.0010 times 8, I'm going to get, oh, I don't even think I need the calculator for that. I think I can handle that. Yep. So got our moles of CO2 and our moles of oxygen. Let's add those together and we should get our total moles. So let's add it all up. 0.0080 plus 0.00. Whoa. Sorry, sometimes I'm like Stone Age in how I like add these things together. So if we add, oh, let me type it, man. It's like painful. It's like watching me try to use my calculator and add things together. It's not a nice experience, homie. Okay. And that's going to equal 0.0155 moles. So if you add the total moles of oxygen to the moles of carbon dioxide, our leftover oxygen, remember, so this is the CO2 that was produced, this is the oxygen left over, our total moles of gas in the flask is 0.0155. Ta-da! Beautiful. Full marks. I reckon it's time to move on. So let's move.
Keep moving on, keep moving on, keep moving on, keep moving on.
If you push the button,
Like me.
Would you like it?
Like.
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 Okay. A levels. Getting sick of the questions yet? I wouldn't be surprised. A levels are tough. Remember, if you're in year 12 and you're just cruising in your class like, yeah, man, I got level 8, got level 7 in GCSE, I can handle this chemistry A level, yeah, I don't have to do no work, I'll just do what my teacher's not setting me a lot of homework. If you ain't doing an hour a night on your chemistry A level 5 times a week, you are going to flop. Listen, you don't have to. Some people have got commitments after school, after college, and whatever. They cannot put in an hour a night in the week. Then you need to make it up on the weekend. Get your ass out of bed at 8 in the morning and have your breakfast and then get an hour or two of your work done on Saturday and Sunday. You need to do that. If you want to be successful in your A levels, you need to start treating it like it's a job. You're moving towards having a career and having a job where you're going to be getting up every morning 6:30, 7, 8 and going to work. So you need to treat it like that. Okay, you have to get home, you have to study. Remember, if you don't, it's not going to be pretty when it comes to results day. So just remember, A levels aren't easy at all. You don't want to end up like this dude.
I can't handle the stress no more, dog. These damn A levels.
Yeah, so put the work in now so you don't end up completely stressed out. You definitely want to be more of yeah. Right, let's go. I've got a couple of questions here. So let's get into these. The next couple of questions are going to be MCQ, that means multiple choice.
Question, tell me what you think about
chemistry.
Right, let's go. Ziggy diggy do. Okay, let's get into it. A compound contains 40% carbon, 6.7% hydrogen, 53.3% oxygen by mass, which could be the molecular formula of this compound. Recognize this if you did triple, if you did IGCSE. This is the empirical formula. So all we need to do here, bang smack, easy peasy, pudding and pie, is go 40 over 12. 6.7 over 1 and 53.3 over the top of 16. So let's whack out that in the calculator and see what we get. 3.3 6.7. I mean, that's 3.3 recurring over there. And 53.3, what are we going to get? 4 here divided by 16. Oh, we're going to get 3.3. Lovely bubbly. Recurring. So, simplify. when you do empirical formula, you now divide them all by the smallest. So I'm going to divide both of these guys by 3.3, and in fact we're going to divide 6.7 by 3.3, and when we do that we're going to get 1 ratio 2 ratio 1. Go 1 2 1. The empirical formula for this substance is CH2O. How? This doesn't make sense, because when we come over here, none of our multiple choice answers say CH2O. CH2O. What's going on? Well, remember that this question was asking over here for the molecular formula, but they gave us the details to find out the empirical formula. What is the empirical formula? It's the simplest ratio of atoms in a substance. Okay, it's the simplest ratio. The molecular formula is actually how those atoms, the formula of how the atoms actually exist. So we're looking for a ratio of this, and that, if you multiply all of these by 2, if we times them by 2, we get this answer. Okay, so that is the only one that can be the molecular formula. Whatever you multiply our calculated empirical formula by, you won't ever be able to get the other answers. Doesn't matter what you times it by, you have to times them all by the same number. So if we multiply them all by 2, we get C. So that's the answer. Well done if you got it. Let's move on. Question 5. Okay, let's go. When driving a car, a legal limit for ethanol, MR46, what are you thinking straight away? Mass, moles, MR, is 80 milligrams. We're seeing milligrams and thinking, nah, we need to convert. So per 100 centimeters of blood, what's the concentration in mole per decimeter? So first of all, we can work out, if you like, the concentration in grams per decimeter, whatever. We can just convert that to moles, and there's many ways to do this, but essentially let's convert the grams into moles. It's milligrams, so I need to convert that to grams. Let's put that in grams. So let's do 80 over 1,000 and find out what the grammage is of our ethanol. So we're going to do 80 divided by 1,000. Now with these MCQs, sometimes there's 3 elements to the question and you're only getting 1 mark, right? So you need to be swift at them. 0.08 grams. Right, let's convert that into moles, because we need the answer in moles and decimeters. So I got 0.08 grams. I'm going to put that over 46. My moles are 1.73 or 1.74. All of these answers are 1.74. Check it out. So I'm going to round my 1.73 answer to 1, and that's times 10 to the minus 3. Okay, so immediately I've just worked out the moles, right? And I'm thinking, oh, that must be C. C must be the right answer. 1.74 times 10 to the minus 3. Hold your horses. I haven't worked out the decimeters yet. Right, so I've got 100 centimeters. What's that in decimeters? Let's go. 100 divided by 1,000. That is 0.1 decimeter. If I now want to find out concentration, I can bust out this triangle, remember, whoa, which is moles over C times V. So I've just worked out the moles down here, and we just worked out the volume there. So let's do that divided by 0.1, and I'm going to get an answer of B. So you just whack out that triangle. We made the conversions so that we can use the N over CV. Okay. There is another way to do it. You could have just in your head said, right, if there's 1.74 times 10 to the minus 3 in 100 centimeters, how many would there be in 1,000 centimeters? That's a decimeter. Oh, I just need to times 174 times 10 to the minus 3 by 10, remove one of the zeros, it's 1.74 times 10 to the minus 2. So there's quite a few different mental maths ways you can do this, but if you have trouble with that, just refer to those equations that you need to have locked in up here. All right, guys, let's move on and hit the next question.
Keep moving on, keep moving on, keep moving on, keep moving.
Excuse me while I drink some. Whew. Let's go, let's go, let's go, let's go. Right, 3 more multiple choice questions. Well, I've already gone over an hour now, so I always go longer because I've got verbal diarrhea, which is obviously waffle too much. What is the percentage atom economy for the production of ethanol from glucose? So we're looking at the percentage atom economy, and essentially what is atom economy? I don't really like some people say it's the MR of the desired products over the total products. That's a good way to remember it. The MR of the desired products over the total products. What I don't like using MR is you've got to times it by the coefficients are included. Basically, when you're calculating the MR, you don't normally use the coefficients, but with atom economy, you have to. So we want to find out what ethanol is. And ethanol is, what's the MR of ethanol? Anybody know the MR of ethanol? Well, carbon is 12, hydrogen's 1, oxygen's 16. So let's add it up. We've got 6 hydrogens, we got 2 carbons. 2 times 12 is 24, plus the 6 hydrogens, 30. Lovely bubbly. We've then got 30 plus 16 is 46. Gosh, that took me a long time, no? Right, so we've got to do 2 times 46. That is ethanol's MR. That's the desired product. This is fermentation. They're trying to make ethanol from the glucose. We now need the total. So what is the total? Well, the ethanol is 92. But we've got the carbon dioxide. Carbon is 12, oxygen 16. 2 16s are 32, plus the 12 from the carbon is 44. There's 2 lots of carbon dioxide, so 44 times 2 is 88. Plus 88 plus 92 is 180. So we want to do 92 over 180 times 100, and that is our answer. Let's go. Really, it's 51.1%, guys. So you should have got 0.5. Yeah, you get the idea. 51.1%. Let's move on. Sometimes I can talk so much. We need to just keep it.
Keep moving on, keep moving on, keep moving on, keep moving on.
Okay, let's go. Let's get through these questions. So, question 7. Nitration of 1.7 grams of methyl benzoate, MR of 136. Lovely bubbly. As soon as they're giving you grams and MR, you're thinking moles over mass over moles equals MR, blah blah whatever. We're doing that equation. Produces methyl 3-nitrobenzoate, another MR. The percentage yield is 65%. What mass in grams of methyl 3-nitrobenzoate is produced? So, what we want to do here is they've told us yield. They. Right. Yield or percentage yield. Woo! Water. Percentage yield is actual mass divided by theoretical mass times 100. So what we want to do for percentage yield, we want that equation. The percentage yield is the actual mass over the theoretical mass times 100. So if we can rearrange this, we can sort this out. So let's go. We've been given the mass of methyl benzoate. So let's do 1.76 divided by 136. We can work out moles of methyl benzoate. Or do we even need to work out the moles of methyl benzoate? Let's check it out. If I know the moles of methyl benzoate, then I know the moles of nitrobenzene, and we can work out the nitrobenzene. So let's go. So the moles of methyl benzoate, not 1.76, 1.70, idiot, over 136. Let's quickly work this out. Bear with me, divided by 136. Why am I doing moles when I need mass? Well, I need to work out, you haven't actually done methyl benzoate, produces, yeah, 1-to-1 reaction. So we're going to assume it's 1-to-1. So if I've got that many moles of that, I should, with a 65% yield. So what I need to do is find out so that's how many moles of methyl benzoate I have. You might be thinking, what the hell's he on about? So that's how many moles of this one I have. What I need to do now is find out the mass that I should produce of 3-nitrobenzene. So let's do moles times MR. So moles times MR equals mass. So we're going to do that now for the methyl benzoate, which is the product. The 3, God, I'm longing this out, nitrobenzoate. So what we've got to do here is go, we've worked out the moles was 0.0125. I'm assuming it's a 1-to-1 reaction. They wouldn't give us anything nasty, would they? Times 181, which is the MR, and this will tell us the grams in mass we should make, and that is going to be 0.012 times 181 equals 2.26. I know what you're thinking. How can you do all of this for 1 mark? That's the way the multiple choice works. So that is the actual amount we should have made. Come on, baby. I can't write grams, it's not letting me do it. Yeah, grams. So that's the mass we should have made. How much did we make? Well, we got a 65% yield. So our yield was only 65%. Guess what? I can just times that by 0.65 and that will give me my answer. 1.47. So the answer, guys, is C. 1.47. So how did I work that out? First of all, I calculated the moles. Why did I do that? Even without thinking, they told us, they gave us 1.7 grams of methyl benzoate and they gave us the MR. Why are they giving us the mass and MR or something if they don't want us to calculate the moles? So I just worked out the moles. If we know the moles of that, we just assume, hey guys, that's going to tell me how much moles of the other one I should have. So let me work out how much mass I should have of the product, the 3-nitrobenzoate. So we did that and worked out that the mass we should have got is 2.2625. But they then told us the yield is only 65%. The experiment was only 65% effective. You know, they lost 35% of the product. So we then times that by 0.65, which is basically finding out what 65% is, and it was 1.47. So lovely. Let's move on. Question 8. Which compound needs the greatest amount of oxygen for complete combustion of 1 mole of the compound? It's a little bit long, this one. It's basically like writing out the word equation, or write out the symbol equation for each of these, by going plus O2, balancing them, and then seeing which one has the biggest coefficient of oxygen, which one has the most moles of oxygen needed, which is a little bit long, isn't it? And if you had 60 seconds to do this, you'd be like, rah. So let's start with A, and we go, right, ethanol. You kind of have to know the formulas of all of these. So ethanol is CH3COH. We go plus O2, because these are combustion reactions, and that makes CO2 plus H2O. So if I wrote that first equation out and then we balance it, see if you can balance that first. In fact, see if you can balance. I'm going to write all the equations out, and while I'm doing it, see if you can balance them. C2H5OH is ethanol plus O2 goes to carbon dioxide plus water. All of these are going to make carbon dioxide and water. They're combustion equations. Okay, so we're really looking for which one, when you balance it, needed the most oxygen to balance. That's the one that needs the greatest amount of oxygen to be completely combusted. Ethane 1,2-diol. Oh gosh, I'm just going to write 02. Oh my good gosh, I think I've used my 60 seconds up already. I'm behind in my chemistry exam. What's going on? See if you can balance these guys. Methanol, CH3OH. Is that methanol? Yep, my eyesight's rubbish. Plus O2. Right, which one of these guys requires the most moles of oxygen? Hey, you never know. Your teachers might use the physics and math tutor questions in your end of unit exam. So stick around. Stick around, as Arnie would say. Okay, let's balance these up, guys. Which one requires the most oxygens to balance? So hopefully you guys have balanced it. I'm going to write the answers in. So for this bad boy at the start, it's got 2 carbons, so I'm going to need 2 carbon dioxides. It's got 4 hydrogens. I'm going to need 2 waters. I've then got to go 4 Right, so I need, hold on, 4 oxygens plus 2 oxygens is 6 oxygens. I've already got 1 oxygen here, so I need 2.5 oxygens. Okay, let's do the next one. There's 2 carbons in ethanol, so I need 2 carbon dioxides. There are 6 hydrogens, so I need 3 waters. Total oxygen is 4, 7 on the right. I'm going to need 3 here. Why only 3 if there's 7? Why not 3.5? Because I've got an oxygen in the ethanol there. So I've now got 7 on both sides. So the leading contender is ethanol at the moment. Let's do the next one. C2H6O2. All right, C2 again. I need 2 Cs. Check out, there's 6 hydrogens, so I need 3 waters. This means I'm not going to need as many here because this has got 7 oxygens on the right, but I've already got 2 over here, so I only need 5. So I need 2.5 again. Yeah, 2.5. Can't even see that. Basically, so far it's looking like the answer's ethanol. Let's just check this last one. It's going to be ethanol. Yeah. 1. I need 2 waters. That's a total of 2 plus 2 is 4 oxygens. I've already got 1 there. I need 3 more oxygens, so I'm going to multiply this oxygen by 1.5. So the one that needed the most oxygen was B, ethanol. Needs more oxygen than all of the others for complete combustion. Okay. Has it got the highest carbon hydrogen to oxygen ratio? It does. So another quick way of doing that, okay, I would write all these equations out and then balance them. Another quick way of doing that, if you look at the ratio of each of those 4 molecules, ethanol, ethane 1,2-diol, methanol, which one has the highest amount of carbon and hydrogen compared to oxygen in it. And so methanol obviously has got more percentage oxygen in it. So has the ethanediol with the 2 oxygens. Basically, the ethanol has got the least amount of oxygen for its size. And so it's got a lot more carbon and hydrogen, which means you need a lot more carbon dioxide and water to be created. And that means you need more oxygen. Anyway, so you can kind of do it without writing all the equations out. But here we go. Right, guys. I'm literally going to do... Am I going to bother doing one more question? I might finish there and then pick up the... I might pick up next lesson with some more questions. So guys, I'm going to finish there. I'm probably going to do another live tomorrow. So, or maybe later tonight, I'll even bust another one, amount of substance part 2. I'm going to work through all 40 questions. We've got 8 done there. So let's wrap that up for today. Thank you for watching. Nice one. So, yeah, give yourself a round of applause if you made it through. And it's over, and I will see you maybe later tonight or definitely tomorrow for another amount of substance.
You're still here? It's over.